Hello, my name is Mike Rosario, and today we'll be presenting mathematical models of localized muscle fatigue. Our introduction. Researchers analyzed the rate of localized muscle fatigue by testing the models that considered fatigue development and recovery time. In this project specifically, we looked at the MCBZ model created and developed by Ma et. Summary. Predicting localized muscle fatigue is important when analyzing workplace performance and limiting injury risk. Given the number of task-related variables that impact LMF, it is not practical to measure LMF for all possible conditions. However, using muscle fatigue models, or MFMS, we can predict LFM development and/or endurance capability without the need for measurements on an individual level. Researchers tested out two different MFMs, XFL and MCBZ, comparing the two based on the sensitivity of the model predictions to alterations of their parameters. It is argued that such models may benefit the future work from improving their representation of recovery process, particularly how these processes differ across conditions and parameters.
So the equations that came in two equations, one which included fatigue development and the other one which represented recovery process. So here Q of T represents the current muscle capacity with respect to time. F stands for fatigue, R stands for recovery, which are both constants. F external is the external muscle force, which is also modeled with respect to time. And MVC is the maximum voluntary contraction, which is also a constant. Also, there were certain loading conditions that were practiced when analyzing these models. Usually the fatigue process is measured using prolonged isometric contractions, although in this study this was considered ineffective as most work tasks have intermittent resting periods. In this study, a range of intermittent isometric exertions was considered to model the fatigue process. So these are the models that we use to do. These are the Simulink models that we developed in Simulink of both of the equations. The first equation is of fatigue development, or the second equation of recovery process. As you see on the left and right, they both were modeled using the constants.
From here, we can see our Simulink results, which on the left-hand side, we see a graph with a negatively decreasing slope, but that seems to plateau towards the end. And on the right, we can see a positively increasing slope, which also plateaus towards the end. This is expected as the fatigue is a negative value, which is expected to decrease the amount of localized muscle fatigue over a period of time, while the recovery is a positive constant.
So for our conclusion discussion in the results section, a theoretical muscle fatigue model was developed to allow for the monitoring of localized muscle fatigue for a more practical way to track the issue within a work environment. The theoretical model allows for a wider range of utility and requires less measurements of localized muscle fatigue compared to empirical models, which is good for in larger corporations. And additionally, they found that the fatigue parameter had a greater impact on the model than the resting parameter, which potentially suggests that the fatigue equation is superior to the other equation as it is more sensitive to the variables.